Okay, you guys, I wanted to walk you through this practice problem that you find on the Unit 6 practice test because you will see the same sort of thing on your actual unit test. So I wanted to show you how to break it down to make the unit test easier for you. So what you do need is you do need a periodic table of elements and a scientific calculator. You can use your periodic table on your computer, or I have to have one printed up because I'm old school, and I also like an old school calculator. So you'll need those as well. For the test, you are going to need a piece of scratch paper to help you work a lot of this stuff out. So here it starts with aluminum metal reacts with aqueous nickel 2 sulfate to produce aqueous aluminum sulfate and nickel precipitate. In this reaction, 108 grams of aluminum are combined with 464 grams of nickel 2 sulfate to produce 274 grams of aluminum sulfate. So what Bright Thinker is asking you to do, they are going to want you to calculate your percent yield. They are going to want to have you calculate your theoretical yield and like that, and your limiting reactant. So I want to show you the best way to do this, and I'll show you on the next slide. The first thing we want to solve for is the limiting reactant. Then we are going to solve for the theoretical yield, and then we're going to solve for the percent yield. That is going to be the best way to do this, even though they've got the questions out of order. Okay, so we have to go back here. Bright Thinker has already balanced our chemical equation. So those coefficients show that it is balanced, which is great. So the first thing I'm going to do is I'm going to write down what I'm given. So I am given 108 grams of aluminum, and they're combined with 464 grams of nickel 2 sulfate. They also tell us that we are going to produce 274 grams of aluminum sulfate. Okay, now this right here, this is our actual yield. You're going to need that to calculate your percent yield. So they're giving us the actual yield. What we're going to do is we're going to actually calculate the theoretical yield. But we are going to start with figuring out the limiting reactant. Okay, so we need our periodic table. I'm going to start with aluminum. So I'm going to say 108 grams of aluminum. Now what I'm going to do is, since they've given us our actual yield of aluminum sulfate, both of my stoichiometry problems are going to go to aluminum sulfate. So what I'm going to do is I'm going to convert 108 grams of aluminum to moles of aluminum sulfate. And then we'll stop there to figure out the limiting reactant. And then we'll go one step further to figure out the theoretical yield. Save you a little bit of work. Okay, so now I have to find the molar mass of aluminum. So 26.98 grams of aluminum is the same as 1 mole of aluminum. So my grams are gone. Now I'm going to go up to my chemical equation, and I have to use my mole ratio. My mole ratio is going to be a 2-to-1 ratio. Now I want to get rid of aluminum, so my 2 moles of aluminum goes down here, and since I have no coefficient, I have 1 mole of Al2SO4(3). Moles of aluminum are gone, and I'm sitting at moles of aluminum sulfate. Now I'm going to calculate that in a second. I'm going to set up my next stoichiometry problem. Right now, I'm looking to calculate my limiting reactant. So I'm going to take 464 grams of NiSO4. I'm going to convert it to moles of aluminum sulfate. So I have to find the molar mass. So 1 mole of NiSO4. I got to calculate this. So I'm going to come over here. I've got nickel, I have sulfur, I have oxygen. Nickel's molar mass is 58.69. Sulfur is 32.06. We have 4 oxygen atoms, all at 16. So the first thing I'm going to do is 4 times 16 is equal to 64. Now I'm going to add all my molar masses together. 58.69 plus 32.06 plus 64 will give me 154.75 grams per mole. That's the molar mass of NiSO4. So now I can put that right here. 154.75 grams of NiSO4. So grams are gone. I'm sitting at moles of nickel 2 sulfate. Now I have to come up here and use my mole ratio. So now I'm going to use my 3-to-1 ratio. I have 3 moles of NiSO4. I always want my matching substances to be diagonal. Is the same as 1 mole of Al2SO4 3. Now I'm going to calculate. Now don't forget, these are both going to be moles. I'm going to start with my top equation. So you multiply everything straight across. Again, remember you could put a 1 here. I'm going to multiply everything straight across and divide by anything that's on the bottom. So I'm going to do 108 in my calculator divided by, I don't have anything on the top, I only have 1s, so I don't have to multiply it other than multiply it by 1. So I'm going to do 108 divided by, and I'm going to use parentheses on the bottom, 26.98 times 2, close parentheses, and I am going to get 2.00 moles of Al, I don't want to make this too big, I need some extra room possibly, 2.00 moles of Al2SO4 3. Now before I can figure out my limiting reactant, I have to do this calculation here. So again, 464 divided by, I'm going to put parentheses, 154.75 times it by 3, close parentheses, will give me 0.999 moles. So I'm going to round that up to 1.00 moles of Al2SO4 3. So at this point, I compare my answers. So this reactant right here produced the smallest amount of moles. So that means nickel 2 sulfate is my limiting reactant. So that's question number 1 answered. So now the next question I'm going to answer is my theoretical yield. I don't want to do anything with this equation up here because this is saying that it's producing more than it really would, because as soon as the limiting reactant runs out, then the reaction stops. So we're not going to do anything with this equation up here, but we are going to continue our equation, or we're going to continue our conversion right here. I'm going to convert moles of aluminum sulfate to grams of aluminum sulfate. So I'm just going to make this a little bit smaller, give myself a little bit of room. If you give yourself more room, you're good to go. So I had 1.00 moles of Al2SO4 3. So I'm going to convert 1 mole of Al2SO4 3. Now I need to calculate the molar mass. So I'm going to come over here. So my equation is Al2SO4 3. I need to calculate the molar mass of this guy. So aluminum, I have 2 aluminum at 26.98. I have sulfur. That 3 is distributed. Now you got to pretend there's a 1 right here. So I've got 3 sulfur atoms at 32.06. 3 times 4 is 12. So oxygen, I have 12 oxygen at 16. I'm going to do all this math. 26.98 times it by 2 is 53.96. 3 times 32.06 is 96.18. And 12 times 16 is 192. I'm going to add those together. 53.96 plus 96.18 plus 192 gives me 342.14 grams per mole. Now I'm going to use that in the rest of my problem. 342.14 grams of aluminum sulfate. So my moles cancel out and multiply straight across. So my answer is 342.14 grams of Al2SO4(3). This answer in grams is my theoretical yield. And I need that. So now I want to calculate my percent yield. So in order to calculate my percent yield, I need to have my actual yield divided by my theoretical yield times it by 100. So this was my actual yield, and this is my theoretical yield. So up here, well down here I guess I can squeeze it in. I'm going to put my actual yield, 274 grams, divided by 342.14 times it by 100. So I'm going to say 274 divided by 342.14 equals, times it by 100, is going to give me an 80% yield. So now, if you do all that on your paper, you can come back. Our percent yield was 80. Our theoretical yield was 342. And our limiting reactant was nickel 2 sulfate. Hopefully that helps get you by before you take the Unit 6 test. Take care. Have a good weekend.